So we were discussing a particular type of problem. Those problems were having the determination of formula. We were discussing the determination of formula with the help of solid state. We used to know how many particles are there in the body center's unit cell, how many particles or atoms are there in face centered unit cell, octahedral voids, tetrahedral voids, and based on that we were solving some problems on the enrichment classes. Today also we will be continuing that, but maybe our problems today will have little bit more complications. But to start with, I will take an easy one. I will take an easy one. The problem is goes like this. A certain metal fluoride. So it's a metal fluoride. Crystallizes in such a way that if atoms occupy simple cubic lattice corner sites, while metal atoms occupy the body center of the cubes. Question is, the formula of metal fluoride is, 4 options were given. First one is M2F, second one is MF, third one is MF2, and the fourth one is MF8. So obviously from the given question there are two main things. Metal occupies the body center and F atoms occupy the corners. So let us draw it. If you can draw the diagram, the things becomes easier. Now, metal atoms, say metal that means M. Suppose it is this type, and if atoms occupy the corners, so fluoride atoms, that is F, that occupies the corner. So two colors will let you know. So let us first fill up the fluorides. It will be here. It is at the corners. Right. Now, so corner atoms have occupied already. These are the fluoride atoms. And metal occupies the body center. So at the center of it, the metal is there. So this is how it looks like. So we know the contribution. Very easily we can calculate. it is at the center. How many? One atom. It will contribute 1. So it is 1 only. And fluoride atoms, F atoms, it is at the corners. So there are 8 corner atoms. Individually it will contribute 1 by 8. So it is 1 also. So you can see the ratio is 1:1, right? We have solved similar type of problems earlier also. If the ratio is 1:1, it should be, the formula should be MF, which is this one. So that is the correct answer. Now the next one. This one is an advanced level problem. So we have to pay a little bit more attention to it. Question is, a crystal is, I am writing little bit, and the size will be little bit smaller of the alphabets because I have to keep questions as well as answer together. So kindly cooperate. A crystal is made of particle X, Y and Z. Now 3 things are said. Y occupies all tetrahedral voids. So Y occupies all, in short I am writing tetrahedral voids. Here it is also mentioned that X forms FCC packing and X and Z occupies all tetrahedral here there is a small change. Y occupies all octahedral voids. So this is O dot V. And X and Z occupies all tetrahedral voids. Kindly do this change. Now, if all particle along body diagonal, if all particles along the body diagonal are removed, then the formula of the crystal would be, options are given. Option A is X, Y, Z2. Option B is X2, Y, Z2. Option C is X8, Y4, Z5. And option D is X5, Y4, Z8. Now we have to pay extra attention to few things. Y occupies all the octahedral voids. X forms FCC packing. And X and Z occupies all tetrahedral voids. 3 things are same. If all particles along body diagonals are removed. This line is also something new. So now let us draw the diagram first, then we will try to understand what will be the formula. To explain this answer, let us first try to draw the diagram. To draw a little bit bigger because some complications will be there. So this is how the structure looks like. So X is at X forms FCC packing. So X will be present over here. At all the corners. And at the same point of time, FCC, because it will be present at the center of each faces also. Okay. Remember, X is present all the tetrahedral voids. So, where the tetrahedral voids are present? The tetrahedral voids are present. We have seen the diagram in the void video also, that it is present only at the body diagonals. So for FCC, total number of atoms is 4 atoms. So how many tetrahedral voids will be there? 4 voids. Sorry. 2 into 4 voids, 8 voids. And how many octahedral voids will be there? 1 into 4, that is 4 voids. Now, X, the contribution of X already. Remember, there are 8 atoms at the corners. Each contributes 1 by 8. And there are 6 atoms at face centers. And it will contribute half. So before removal of the body diagonal, the number of X atoms will be 1 plus 3 equal to 4. Z atoms, if there are 4 X atoms, there should be how many Z atoms? Obviously, the tetrahedral voids suggest there should be 8 atoms. And since there are octahedral voids occupied by Y, there will be 4 atoms. Now, if a body diagonal, say for an example, this one, suppose this is a body diagonal, it is not necessarily over the body diagonal. If a body, all the particles along the body diagonals are removed, we have seen earlier that across the body diagonal, the center of the 2 tetrahedral voids are remaining. So I have to mention here, where is the position of tetrahedral voids? 2 at body diagonal. And octahedral voids, what is their position? They are present. There are 2 types of octahedral voids. One at body center plus edge center. I will always refer, because all those diagrams I cannot draw it here. Please refer to that video where I have drawn the location of tetrahedral voids and octahedral voids. Now you see, if all the particles along the body diagonals are removed, now if I erase this part and if I recalculate, because you are already having the question, you can pause the video and can write the question first. So after removal, two X will be removed, which is present at the corner. So now number of x that will be present. Earlier there was 8 into 1 by 8. Now 2 corner atoms will be removed, so it will be 6 into 1 by 8. Plus the face center atoms will remain as it is, so it is 6 into 1 by 2. How many Z atoms will be removed? Remember, Z atoms are present at the octahedral tetrahedral voids, and there are 2 tetrahedral voids at the body diagonal. So 2 Z atoms will be removed. So earlier it was 8, now it will be 8 minus 2, which is 6. And what about Y? Y means we are talking about Y is present. Here you can see there are 4 atoms because it is octahedral voids. So there are 2 types of octahedral voids. One at the body center. Obviously the body center atoms will be removed because the body diagonal goes through body center. So if earlier there were 4 atoms, it will be 4 minus 1, which is 3. Body center atom from body diagonal will be removed. H center will remain as it is. So now the new scenario will be, here it is 6 by 8 plus 3. So I think it is 6 plus 30 by 8. So it is 15 by 4. So now the new formula will be x 15 by 4, y 3, z 6, which is x 15, y 12 and z 24, which means x 5, y 4, z 8. This should be the final formula. So I think this one is the correct answer. Next one is also an advanced level problem. The question goes like this: a crystal is made of particles A and B. A forms FCC packing, and B occupies all the octahedral voids. If all the particles along the plane as shown in the figure is removed, then the formula of the crystal will be, 4 options are given. Options are A, B, option B, A5, B7, option C, A7, B5, option D, none of these. Okay. So this one is important. Along the plane in the figure is removed. All the particles along the plane, the figure goes like this. Draw it bigger. Here, according to the figure, the plane which is removed is this plane. This plane is removed actually. This plane is, all the particles along this plane is removed. So now let us see. First of all, it is made up of particles A and B. So A forms FCC and B occupies all the octahedral voids. So according to that, if B occupies all the octahedral voids and if it is FCC, so there are two types of octahedral voids as we know. One is at H center and one is at body center. And we know the position of the FCC atoms, they are present at the corners only. So let us first locate the position of A. They will be here, all the corner atoms. And all the face centers also. So this is the position of A. Now, there are two types of B atoms. You know there are two types of octahedral voids. Body center plus H center. So let us first draw the H center atoms. Why they are present at H center, why at body center, all this has been described in that video. I will try to give the link in the description so that you can find out exactly which video I am talking about. So you can see there are 12 H center and one atom at the body center. Now carefully see. If all the particles along these are removed, first of all, if it is not removed, what is the scenario? If it is not removed, so here there are 8 corner atoms, each contributes 1 by 8, plus there are 6 face center atoms, each contributes half. And if here also it is not removed, body center its contribution is 1 into 1, and there are 12 edge centers which contributes 1 by 4. I hope this much is clear to everyone. So here it is 1 plus 3, which is 4, and here also it is 1 plus 3, which is 4. If nothing is removed, now after the removal, so how many of the atoms will be removed? Let us see that. So for A, 4 corner atoms will be removed. Earlier there was 8 atoms, now there will be 4 atoms only. So 4 atoms are remaining as of now because 4 of them are removed. I hope I am clear. Because 8 was there, 8 atoms were there, 4 of the corner atoms are removed, 4 of them are remaining. Each contributes 1 by 8 plus out of the 6 face center atoms, 2 of them, these 2, are directly falling onto this plane. So how many of them are still remaining? 6 minus 2, that means 4 of them are remaining, and each contributes half. So here the situation is, it is obviously half plus 2, so 3 by 2. Sorry. Half plus 2, so it is 5 by 2. Now, let us see for B atoms. There are 2 types, body center. See the position of body center exactly onto the inside that plane. So that will be removed, obviously. So it will be 0 into 1 because that is removed. Plus, how many edge center atoms will be removed? In case of edge center, you will see this edge center which is exactly onto this plane, and this edge center. You might have a confusion by looking at this diagram. Look at this edge center. Actually it is behind the plane, right? It is not onto the plane. The plane is almost parallel to the body diagonal like this. So this one will not be inside the plane at all. Only the body center atoms, that's why I have kept 0 into 1. And these 2 edge centers. So 2 edge centers will be removed. Earlier there was 10. Now it will be, earlier there were 12. Now it is 10. 10 into 1 by 4. So it is giving rise to 10 by 4, which is nothing but 5 by 2. So we have seen after removal, the contribution of A will be 5 by 2 and the contribution of B is also 5 by 2. So the formula should be A 5 by 2 and B 5 by 2. So which means it is nothing but the simplified formula should be AB. That means this answer is correct.